So 6.0, we added the 6.0 because a lot of times people forget about these beautiful exponential properties that you had from when you took algebra. Whenever that was, think back about those days, like, oh, the algebra days. Do you remember these properties? I don't know. So first one, anything that raised to the 0 power, it does not matter what it is, it's always going to be equal to 1, as long as that base is not 0. When I say base, it's the number that has the exponent with it. If I'm dividing with the same base, you have to be sure that you have the same base, the exponents here would be subtracting. So an example of that could be something like x to the third over x to the fifth. This would give me x to the negative 2. However, jump over here, you should not have any negative exponents. So if I have a negative exponent, then I can put it into a fraction, put it on top or on bottom. So this final answer, that would be equal to x equals, or raised to the negative 2, be 1 over x squared. If it was negative on bottom, let's say, I can move that on top to make it positive. You should never have any negative exponents. What if we are multiplying with the same base? So this multiplying with the same base, you're going to add exponents, which is different than when I have a power. When there's a power, this would be like if there was a 1, if these were both raised to the first power, then you multiply exponents. So multiplying with the same base, add exponents. Power, you multiply exponents. That can be kind of confusing. So again, here, if this a base was raised to a power, you would multiply those together. Just like when here. A lot of times I will say, you'll hear me say, don't be greedy, because greedy is not fun. Being greedy is not fun. So I'm going to do these 3 problems, A, B, and C. So there's multiplying, there's no power. That's the first thing I check. Now, a lot of times once you get used to this, you don't have to write it out in this format, but I tend to write them out with the same base next to each other. So first thing, these 2 are just multiplied together. So I can do 5 times negative 3, negative 15. Because those are just whole numbers. That's way back to, I don't know, I think you learned multiplication in 4th grade, 3rd grade, who knows. I can now use this property when I'm multiplying with the same base. You actually can solve this in 2 different ways. You can multiply with the same base, or you can change your negative to a fraction and then solve it this way. I'm going to add these 2 together. So 3 plus negative 4, give me a to the negative 1. This should not have a negative exponent. You can have a negative number, go for it, like live your life to the fullest. So that's negative 15. That does not go in the bottom of a fraction because this does not have a negative exponent. Just this a value does. So this right here would be my final answer. You can have this little one if you want to. You don't need to though. Now this is where you have to be careful. I have a power, so I have to give it to everyone on the inside. Do not be greedy. The reason I say do not be greedy because a lot of times people forget about this whole number. Now, you should know that when I have something, a negative raised to an even exponent, it's going to become positive because this is saying negative 4 squared. If this was negative 4 cubed, my answer would still be negative. Negative 4 squared. If you're confused about that, put a little star here so then you can ask me. But negative 4 squared would give me 16. I multiply power to a power, you multiply an exponent. So negative 3 times 2 would give me a negative 6. 5 times 2 would give me 10. Again, you should not have any negative exponents. We don't want them. This 16 does not have a negative exponent, and this y does not have a negative exponent. Just the x has a negative exponent. So that would be my final answer. And the last one. Here, I can simplify all of these using this property right up here. Now, a couple of things when I'm going to be going through this. You can still subtract the top minus the bottom, get a negative, and then simplify. You can do that each time. I'm also going to be explaining my thinking process a little bit differently. Okay, so the 4. It doesn't have anything to simplify with, so it's just the 4. Now, if I look at my a's, this a is to the first power. When I look at my a's, I know I have more a's on the bottom of the fraction. So I know that my a should end up on the bottom of the fraction. Once I have that thinking process done, I can do the larger exponent, subtract the smaller one. So 5 minus 1 would give me 4. Now, if I wanted to do it this way, the 1 minus 5, I would get a to the negative 4, and then I would just have to move it on bottom. So either way, you should still get the same answer. And then b's, so I have more b's on top. So my b should end up on top. And then I'm going to do 6 and take away 1, would give me 5. My 3's, now again, if you were to do it this way, it would be c to the 3 minus 3, which is equal to c to the 0. We know anything raised to the 0 power is 1. So technically, these two just cancel each other out. I did not need to have that long. Right now, you should pause the video. Pause the video and try to do them yourself. The next 3, D, E, and F. Try to do D, E, and F by yourself. Pause. Did you pause? Hopefully you paused. So this first thing, what I did first is because when I have multiple things like this, I like to get rid of these negative exponents right away. So from here to here, all I did was get rid of negative exponents. This negative I put on top. This negative I put on top. This negative I put on bottom. Because the negative exponents will change your numerator to denominator, denominator to numerator. The z stayed. My 2 over 6 simplifies to 1/3. Both x's were on top. They were being multiplied, so I add these two together. My y's were opposite each other, so I'm dividing. There's more y's on bottom, so I put the y on bottom. So 3 take away 2 would give me 1. You don't have to write the 1 there, but you can if you want. My z's, there's more z's on bottom. So what did I put my z on bottom? And z, this is 1 up here. So that would be 1. Next one, power to a power. Power to a power, you multiply. Don't forget, don't be greedy. There's like a little 1 here. Every whole number has a 1 exponent. Every one. It's like magical. It's invisible. So when we do a power to a power, we multiply. We get 4. So 2 to the 4th is 16. That's where that comes from. If you're not sure about your powers, then you should probably use your calculator. But you should get used to seeing powers of 2 and powers of 3. Power to a power here, you multiply x to the 12th. Bing, bada, boom. And the last one, again, not everyone has to write this step, but just so you can visually see, these are my whole numbers, so I wrote them next to each other. And since there's no powers out here, these have the same base, so I wrote them next to each other. Now, again, I could change this to a fraction and solve. I chose to leave it as a negative for this case. Wait a second, Ms. Ruckman, but why did you do it over here? Well, one of the reasons I did it over here is because I knew it'd be easy to still add these two together and get my answer. The reason I did not keep negatives over here, because this is a lot harder to stay on track. There's a lot of different variables. There's a lot of different negatives. So that's why when there's a fraction given with negatives, I always change to positive exponents. If there's just one variable with a negative, then that's where I personally choose to keep it as a negative. So I did 2 plus, because these are multiplying, so 2 plus negative 1 gave me 1. And that's all we got going for this 6.0. You, I'm talking to you, have a great day today.